Assalamualaikum and a very good morning. My name is Nurul Farhana binti Muzani. I will talk about the product background and the purpose of this project. The automobile sector is a crucial driver of every expanding economy. The automobile industry includes both the automotive and the auto component industries. Engine parts account for 31% of component manufacturing, followed by drive transmission and steering component which is 19%, suspension and brake component which is 12%, electrical component is 10%, equipment is 12%, body and chassis is 9% and the others is 7%. This project report focused mostly on the production of automobile pistons, which is one of the most demanding engine components. A piston is a cylinder-shaped part that moves up and down on pressure-tight chamber or tube. To generate or transfer motion, the piston action pressurizes a fluid which might be a liquid or gas. The use of piston is what gives a piston engine its name. Of course, an automobile piston assembly is very complicated. It is made up of multiple components and operates in a harsher environment. It is also more substantial and constructed of metal. The piston of an automobile engine is built of material that can handle pressure, instant heat, and variety of the circumstances. Next, the problems. The piston is one of the most crucial components of an engine. A company that manufactures piston is experiencing piston failure owing to insufficient heat dissipation and failure owing to high combustion pressure. As a result, it must be engineered to withstand damage produced by the combustion process, high heat and pressure. The objective of this project, which is have three. The first one, to study and understand the structure of the engine piston in the manufacturing process. Next, to define the material that will be used to create an engine piston. And lastly, to determine how much energy is required in the manufacturing of pistons.
Assalamualaikum. Hi, my name is Nur Anis, MA19022. In this video, I will explain a little bit about the material and design of piston. The first one, I will explain a little bit about the material for piston. The material of design of piston have an impact of an engine overall durability and performance. The majority of piston are constructed of an aluminium formed in a mold. Cast aluminum alloy is lightweight, has a high structural integrity, and is inexpensive to manufacture. Aluminum loss weight reduces the overall mass and force required to begin and maintain piston acceleration. Aluminum alloys are also the chosen material for piston in both gasoline and diesel engines because of their unique properties such as low density, high thermal conductivity, ease of machining, great dependability, and excellent in recycling. Chemical composition, process condition, and final heat treatment are carefully controlled to produce a microstructure that provide the needed mechanical and thermal performance. Particularly is strong thermal failure resistant. The next one is designed for piston head. Pistons have a feature that performs specific function when the engine is running. The majority of the inertial pressure and force generated by the combustion process is applied to the piston head or crown. Due to rapid directional change, the piston pin area is subjected to a significant amount of force. Piston head consists of five components. The first component is crown, the second one is ringland, and third oil ring groove, fourth skirt, and the last one is V-spin boss. The crown is the upper surface of the piston closest to the cylinder head is subjected to tremendous forces and head during the normal engine operation. The ringlands are the relief cut into the piston side profile where the piston ring sits. The third one is oil ring groove, a recessed area around the piston perimeter that is used to keep a piston ring in place. The fourth one is skirt, the part of the piston nearest to the crankshaft that helps the piston alignment as it passes through the cylinder bore. And the last one is re-spin bores, a bore that links to the small end of the connecting rod to the piston by a re-spin. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I would like to explain about the flowchart of the manufacturing piston by casting process. At first, at the foundry, the die is prepared for accepting molten aluminum alloy at the foundry by heating its operational temperature for around 1 hour. The procedure begins by heating the aluminum alloy to 700 degrees Celsius. And after that, the material is allowed to cool inside the die being placed in a container of hot water. Following that, the casting is prepared to provide the better quality. And next, for the pin boring, the judgment pinhole on the piston casting has been rough machined and the locating bunks, which is the casting base, has been machined to allow the casting to be placed in other machine. A basic ladle is used to turn the locating bunks, and then a pin borer is used to drill the pins. And next, for the turning, the precious CNC lathe machine are used for this producing the piston casting. The casting are bunk into the ladle and secured in with a solid rod insert through a judgment pinhole. The piston is now ready for the final stage production. And for the finishing process, we have uh, a drilling oil holes in judgment in the first stage of the finishing procedure, and grinding the piston is machined to the final size in this procedure, and reaming. Uh, and reaming, this is the last machining step, which is involve immersing the piston in an oil bath and simmering it to the necessary size. And for the last one, pin and fitting and final inspection. The piston is the clean and fit with a judgment pin and size and categories then before being dispatched. That's all for the explanation of the flowchart of this process. Thank you.
Hello, I am Mohammed Zafran bin Zamrus, NA19071. I will be talking about the cost and energy usage of making a piston. In general, all parts of a piston are made of the same material. However, different types of materials can be used to produce different design or grades of piston. The table shows the cost of materials in kilograms to make a piston. As we can see, there are actually wide ranges of aluminium that can be chosen to manufacture a piston. Even though the difference in density for these materials is very small, it actually results to different performance of the piston, such as thermal conductivity, wear resistance, and also strength. Next is the energy usage by each machine. The oven can use up to 800 kilojoule, which is equivalent to 0.22 kilowatt hour, to heat the aluminium alloy to 700 Celsius, which is the melting point of the materials. Next, to operate a lithium machine, it will usually use an average of 3.2 kilowatt hour, considering it takes on average load of 40% for 4 hours a day. Finally is the CNC lithium machine, averaging around 2.5 kilowatt hour to operate. Of course, all the numbers can vary a lot depending on the types of the machine itself and also the design and material of the piston used.
Assalamualaikum, a very good day to my respected lecturer and my fellow friends. My name is Masita Fitrah binti Abdul Aziz and my ID is MA19053. So at the end of this project report, I would like to elaborate our discussion at this final report. So we have the final product. We have discussed about the what we want, what the process we choose to make a piston. So here we already choose the casting process method to cast a piston. So here why we choose the casting process, because casting process is very good and cheap. It's also quite affordable for everyone and it's quite sustainable to use for everyone. And also in this casting process, it's also has high thermal conductivity to this casting when we will handling with the molten such as aluminium and grey cast iron. And also we need to do this casting process is because we want to create a sustainable product. We want to make the piston with high quality but affordable at the same time. So here we want to avoid any grain that created in the piston. So whenever the piston handle with the high or low pressure, we can make that piston become sustainability. So it won't crack or leak with oil. So the engine won't be damaged. So that's all for our discussion. Thank you.
As a conclusion, by the end of this research, we will have a better understanding of the structure for piston manufacturing process. As previously stated, the cost of materials for each piston varies. The weight of grey cast iron is higher than the aluminium alloys. In terms of energy consumption, we can observe that three approaches are utilized in the piston production process. As a result, the final energy use values varied amongst the three methods used.